Okay. So as I said, in Italy we associate the boards for reclamation to the boards for irrigation, and also in other countries. Why do we do that? Because when we deal with alluvial areas, alluvial flat areas, and in Italy we have several of these areas. Alluvial means that they were originated by siltation of sediments brought by rivers. And typically these areas are very flat. Think about the region where we are now. They are very flat, and originally they were covered by marshes because the river bringing the sediments sometimes floods, and given that the area is very flat, after flooding, this area don't dry up because the slope towards the sea is very small. And therefore, originally, starting with the Romans and even the Etrurian before than that, in Italy and also in other countries, we realized that these flat areas were unhealthy, and they tried to dry them up. In order to dry them up, they built canals for drainage canals. And these are to be built with a well-conceived plan, because given that the slope is very reduced, the canals have to be designed very carefully in order to be efficient. Otherwise, if you don't design them carefully, of course the drainage doesn't work. And sometimes in order to support the action of drainage, we use pumps. Okay, and these canals are managed by reclamation consortiums, and they are called consortiums because they were originally built by the farmers. The farmers got together, they realized that they need a collective effort in order to dry these areas, and they decided to join together to put the money on the table themselves, and then in order to build these canals. And they serve more than one farmer, of course, in general. And later on, these consortium were also partially financed by the state. So presently, this reclamation consortium, which we call Consorzi di Bonifica, presently they are partly financed by the owner of the lands and partly by the state. This consortium, given the fact that they serve areas that are prone to agriculture, because of course these flat areas, because they are flat and because the soil is rich of organic content, they are very good for agriculture. And therefore these consortiums thought to use the same canals that they use for draining the land. They thought during the summer, during the dry season, to use the same canals to bring water for irrigation. And therefore they became reclamation/irrigation consortiums. There are several of these consortiums working on the Italian landscape, and also in this region there are, if I well remember, 6 consortiums working in a collaborative way in order to make sure that drainage is efficient and irrigation is efficient as well. Keep in mind that if we decided one day to stop the maintenance of these canals, everywhere here we would get marshes back in a very limited time, like a few years. And these canals need a constant maintenance. And this is why these institutions, which typically originated in the Middle Age, around the 15th century, 16th century, this is the reason why these institutions survived during history, survived to emperors, to kings, to wars, to everything, because they are strictly needed and they need to continuously operate, because, as I said, stopping maintenance even for a few years, like 4 or 5 years, would cause flooding and then marshes coming back, and also agriculture suffering. So this is why these institutions have a so long history, and they always survived to everything that happened. So one of these institutions is the Consorzio del Canale Emiliano Romagnolo. Consorzio Canale Emiliano Romagnolo. which they decided to set up testing facilities in a field experimental site, testing facilities finalized to test different irrigation techniques. So they basically test sprinklers, test the efficiency of gates operating on the canals, and they basically test what is called precise irrigation. What is precise irrigation? Precise irrigation consists in delivering directly to the plant the exact amount of water that the plants need. And therefore it is realized through maybe sprinklers, but more frequently through pipes that drop water directly where the plant is. And these pipes need to work very efficiently because, of course, as I already mentioned to you last week, if they are supposed to deliver the exact amount of water that the plant needs, this implies two things. First, a good estimation of the required amount of water by the plant. Second, we need to make sure that that amount of water is actually delivered, which is not easy, because we cannot test every day if the pipe is working. We need a kind of quality assurance procedure. And this is why they decided to test these irrigation techniques. The result is an experimental site where they continuously make tests, and also they make dissemination. It's open to farmers to check what are the several different alternatives. It's open to students, and also it's open to the public in certain cases. So what is the reason why we go there? The reason is that, as you know, water for irrigation is the main water demand that we have to deal with at the global level and also at the national level, at the European level. And it's basically, irrigation covers about 70%, and this percentage is reliable at both the global and the local level, 70% of the human consumption of fresh water. And water for irrigation means that basically water is taken from somewhere and then evaporates. So in a way the hydrological cycle is, the length of the cycle is reduced. The water doesn't flow anymore along the river, doesn't reach the sea anymore, it evaporates directly. Given that this is the most important demand of fresh water for human consumption, it's clear that this is the sector, irrigation is the sector, where we need to concentrate if we want to make our water use, global water use, sustainable. And therefore, optimizing irrigation is recognized today as the main strategy for making, again, water uses sustainable at the global level. And of course, there are several problems. Of course, we need financial support to make this. We need knowledge. And this is why they decided to set up this field, this experimental site. A few words on how they work. First of all, where is water taken for this irrigation board for the Consorzio del Canale Emiliano-Romagnolo? It is called Consorzio Canale Emiliano-Romagnolo because they manage a canal which is called Canale Emiliano-Romagnolo that takes water from the Po River and then crosses a large portion of this flat area from more or less Bologna to the east. So Bologna, Imola, Forlì, Cesena, the canal crosses this flat area and delivers water for irrigation. So the situation basically is that you have this flat area, which is the Emilia-Romagna region, where the Po River flows to the Adriatic Sea, and so this is the Po River. This is the Romagna region. So there is somewhere Bologna here, and then there is Ravenna. Forlì-Cesena, and etc. Basically, they take water somewhere, and I don't remember exactly where there is the intake. We should look on a map, or we should ask them. It's not very important, but they take water from this artificial canal, which crosses all the region, and finally delivering water for irrigation. And basically, it's an alternative to the Po River, let's say. And at the end of the story, it goes again to the Adriatic Sea, because excess water is to be delivered somewhere. And here there is a pump in order. I don't remember if there are pumps or water flows by gravity. I think there are both. They use water by gravity when the Po River is high, and then there are pumps when the Po River level is low. But this is something that we may ask them, okay? And then, of course, there are other canals which are served by, in some cases, pumping stations through which they deliver water to the farmers. This is the way they work. And this canal was built relatively recently. And let me see, I think there is plenty of information on the web. And so, going there, it's an opportunity not only to check how the experimental site works, it's also an opportunity to ask them any question you may have related to how irrigation boards work, how they manage the canal, how is water taken from the Po River. Other questions may be if they have other sources of water for feeding the canal, like groundwater, etc. They told me that they had the cable, instead the cable is not here. I don't understand. Oh no, it's here, sorry. And so any question that you may have related to managing irrigation is appropriate. The technicians are very good. Usually this is a kind of a visit that I enjoy very much. The bus is paid by the university, and anything else is not covered. So I think, I'm not sure, maybe that we make a stop for a coffee, and the coffee is covered by me, but any other expense is not. Okay, the coffee for sure. And every year when I close the courses, I offer the coffee to the students. And this is an opportunity to enjoy the coffee somewhere else other than the bar of the university. Okay, it's a bit small, I don't understand why. Let me check. I think they changed something. Let me check, because this is a bit... so let me check this. What happens? It's not a good thing. No, this is not good. Let me try this. Let me see what happens here. No, not good. Okay, let's stick on this solution. Yeah, I'm not sure whether. Let's see. Give me 1 second, because I'm not happy with this. This is nothing that we can. Okay. Let me see. Aspetto. Let's see what happens. Zoom. Okay. One second. Okay, let me go back here. Back again. Still. Okay, we are almost there. Just 1 second. Okay. It's not what I wanted to get, but let me check. Okay, let's try, because we can't spend the whole day in getting the PC working. So let me check what I wanted to show you. Okay, there is a Wikipedia page. I hope that still it's not what I. There is a Wikipedia page, basically, and with a map. Okay. With the map here. So basically, you can see here, up there is the Po River, and the canal is this one. So basically, I think, let me see, or this one. So water is taken by upstream Ferrara a little bit, and then there is this yellow line, which is the canal crossing this flat area. Okay. Other things that I should say before leaving, I think we are done. We are okay. And again, if you have problems in finding me Monday morning, just send an email. I'll be connected. Okay, very good. Now, second thing before we move forward, we were supposed today. I asked you a question on Tuesday. So the question was why our clients want to make the environmental flow spillway, the width, they want to reduce the width of the environmental flow spillway So, width, environmental flow, spillway. Okay, so did you think we have any reply to this? Environmental flow, spillway. So, who has a proposed reply? Nobody. It's not possible. Yeah, please.
Excuse me, I have a question. You mean to reduce the width of the environmental flow is the volume of the environmental flow?
No. Basically, what I said is that the environmental flow that you have to release is the same. It doesn't change. And what is the definition of the environmental flow? The definition is that, okay, we know what it is, but what is required by law? It is required that you don't take any water from the river unless you have the environmental flow released downstream. My question is related to how to release it. And therefore, basically, if I go back to the figure, let me get the figure of the spillway. Unfortunately, this is, I need to dedicate some more time to this because it's, to this projector because it doesn't work well. Okay, but in any case, let me get this figure. So, okay, this is the figure, this is the environmental flow spillway, which is located at a lower elevation with respect to the other spillways for the reasons that we know. And it has a width. So, basically, it's something that we have to design, and I told you, typically it's 40 centimeters, 50 centimeters. And my question was, why that width? So, I told you that our clients, they want to make it not as large, like 20 centimeters, but we say no because actually we want fishes to go through it, and therefore we say 40. But my question was why they are interested in making the width on the environmental flow spillway reduced. And another thing that I said is it's not regulated. We don't have a gate there. So water must flow without any facility that allows us to regulate the environmental flow. Any other suggestion on that? It's not easy, I understand, but no idea. So basically, you know, we could make it even larger. If you suppose that the river is large enough, we could say, okay, let's take it 1 meter wide, because so we are sure that fishes pass through there. And also it's more accessible, but they say absolutely not.
To reduce the cost?
So and so.
So we have more velocity?
No. Let's say, not to reduce the cost, but to increase the benefit.
Maybe for flood mitigation?
Sorry?
Flood mitigation?
No.
Because of you reach the diversion spillway sooner?
It's a bit close, but not really that, because you know the diversion spillway, you locate the elevation by imposing that you reach it once the environmental flow is released. Okay, first of all, did everybody understand my question? Yeah, yes, okay, so it's not a problem of understanding. Okay, now, let me tell you the reply, okay? And then I make some considerations. What happens here? So you have to think at what happens. You have to look at the process. So you have to think at the functioning of this device, of this barrage. So every time that, I give you a suggestion, every time that you have a question, something that you don't understand, look at what happens. So the ideal thing would be to go there to look at the functioning, and I'm quite sure that if you look at it, you understand why. But if you don't have the opportunity to look at it, you have to figure out. So what happens here? Okay, as I already told you, let's suppose that we start from a dry situation, and then some flow arrives. Okay, the flow goes downstream through the environmental flow spillway because it's the lower one. And let's suppose that the flow from upstream increases. Then, as I said, the water level increases upstream in the pool that we originate upstream. The water level increases. By increasing the water level, you increase water flowing through the environmental flow spillway. Why is that? Because you remember that there is a relationship to compute the flow through a spillway, which I write again here, which says that in general the flow through a spillway Q is given by a coefficient μ, which we take as a constant, times the width of the spillway, okay, the width that our clients want to reduce, multiplied by what I call delta H to the power of 1.5, 3 divided by 2, times 2g to the power of 0.5. Okay? So, what happens if I increase the water level upstream in the pool? The flow through the spillway increases, which is what we want. Okay? And then at a certain point, I get to a water level upstream so that the flow through the spillway is equal to the environmental flow, which is fine. At this point, we start getting water to withdraw water for our purpose. And our benefit, the larger the water that we take, the higher the benefit. But with increasing flow upstream, this delta H increases as well. And we want this delta H to increase because if it doesn't increase, we cannot get any flow. So in order to get our design flow, we need this delta H increasing again. But if this delta H increases, the flow through the environmental flow spillway increases as well and becomes larger than dmv. This is something that the client doesn't like. Ideally, the client would like that once that we release the environmental flow downstream, then it doesn't increase anymore. So ideally, they would like to put a gate there, here, because they want to reduce the area, the cross-sectional area of this release of water. Because ideally they want to keep constant the release equal to the environmental flow. But they can't put a gate there. This is one of my premises. I said we can't put any regulation facility on the environmental flow spillway, and therefore the result is that the flow, as they get water, the flow through the environmental flow spillway increases and becomes higher than the dmv. This excess of flow through here, it's a lose for them. It implies a reduced benefit. How much this flow increases for increasing water level upstream? The increase is given by this relationship, and you see that this one, the larger the width, the larger the water that for them is consumed. This is the width. So they realize this, and therefore they say, please reduce this. Because it's a way to limit the excess flow through the environmental flow spillway. It's not an easy question, but you should have found your reply by thinking at how it works, at the processes, thinking at water flowing through this barrage. And this is a general suggestion that I give to you. There is a say that is attributed to Leonardo. Actually, it seems that he didn't say that, but we are not sure. But there is a say attributed to Leonardo. It seems that he said once, when you deal with water, you first have to use reasoning and then the theory. And which means use expert knowledge first and then the theory. And indeed, it's, I think it's a useful example. So when you design something like that, try to figure out how it works, and then use the theory. Okay, is it clear, the reply? Okay, finally, I asked you, I anticipated to you that today I would dedicate the first part of the lecture to getting questions from you. So, and I said, I wanted at least one question each. Let's see if you have questions. So let's open this question answer. And let's see if you can find questions which I can't reply to. Who starts? First of all, raise your hands if you have a question, really. Okay, almost everybody. Okay, I think that, let's say we have to be cavalieri, as we say in Italian. You start. No, I meant him.
Allora, I saw a project on the internet. I want to know for which reason was developed the Cassis method by SciScape, is Swiss Institute for Speleology and Cassis Studies, and what was the outcome of this?
Sorry, I don't understand. Okay, can you please reply?
For which reasons was developed the Cassis method?
The Darcis.
The Cassis, con la K-A-R-S-I-S.
I don't, just 1 second. Sorry, it's my English that it's W.
No, Y.
Karstic.
S.
You mean karstic? You mean
Is.
what is karstic? I don't understand. Sorry.
I found it was a method to study, was a method developed by SciScape, the Swiss Institute for Speleology, and
Okay.
to study, I don't know, the aquifer, the Cassis aquifer.
Okay. A pragmatic. I didn't know that. So let me see. A pragmatic approach to karst hydrologic system conceptualization, assessment of groundwater reserve. Okay. What is your question?
I want to know what is the outcome of this and for which reason was that.
Okay. Basically, I didn't know about this, and I still don't know. And I can realize from here that it's a method to study karst systems. And so I can provide a preliminary reply. So, what is the problem with a karstic system? A karstic system, basically, it's a karst phenomenon. It's a water flow that takes place in karstic areas and is such that the rocks in the substrate means beneath the soil, usually at a certain depth, we have a rock substrate, and the soil is the result of the degradation of the land cover, which basically contains some organic content. And the depth of the soil is varying, but if you go very deep, you find rocks at the end of the story. And if the rock substrate is erodible, it may happen that water flowing over it erodes this substrate and digs tunnels like caves. So most of the caves that we visit open to the public, they are located in karstic areas. And karstic flow is a preferential flow. It's also called preferential flow. What does it mean? It means that when this kind of pipes underground pipes develop, you have the flow of water in the underground taking place at a high velocity, because they are like rivers, but they are buried rivers. And this is an anomalous situation, because usually infiltrated water travels very slowly. We studied it. We said the velocity usually can be the dissipation of energy due to the kinetic component of the flow can be neglected, because velocity is very low. But in karstic areas, and in karstic systems, indeed this doesn't apply, so you have preferential flow. And the preferential flow is something that is a bit concerning, because if we don't see it, we model groundwater resources in a way that it's not appropriate. And the direct consequence of the karstic flow is that, first of all, you have a quicker reaction of groundwater to rainfall. And this is a reason of concern, because it means that you have a groundwater flow that is reacting very, very fast, and therefore it may originate floodings. When the groundwater emerges, if the travel time is much reduced with respect to what we suppose, flooding may be originated for obvious reason, intuition. You get a storm, if the groundwater flow, if the flow is slow, you don't get a flood. If the flow is very fast, you may get a flood, because basically you get water all together in the point where people live. So this is one reason of concern. The second reason of concern is that groundwater resources behave in a different way with respect to what we think. And therefore it means that we may underestimate or overestimate water resources. And it may also imply that water that rains in a particular location becomes available very far away from that location. And therefore we basically make a mistake in the estimation of water resources available.